Hello students, welcome back. Let's do one more problem from 5.6. I assigned a lot of problems here as required problem set, so I guess I can spare one. Let's select the last problem, number 15. Unlike the previous problem, this is not a gimmick example at all, and it'll turn out this is a significant problem. Okay, number 15. And here it is, t y double prime minus y prime plus 4t cubed y is equal to 4t to the fifth power and y1 of t is given as cosine of t squared y2 of t is given as sine of t squared. Unlike the previous problem here, this problem explicitly gave you the solutions of homogeneous equation. So step 1 of the previous problem is redundant. It's unnecessary here. One more thing, please. What is the fundamental difference between the previous problem here and that problem? Do you see it? The fundamental difference? The left-hand side, all the coefficients are constant. Here, we have variable coefficients. Because of all those constant coefficients here, it was pretty easy to find out the solutions of homogeneous equations. All you have to do is to set up the characteristic equation and find out the eigenvalues. But even more importantly, variation of parameter was not really meaningful. We could do the other method like this. Go to solution 2. Step 1 is homogeneous part. Once you get that, make sure that e to the t power, this coefficient over here, is not an eigenvalue. And then we set up, educated gets like this, c times e to the t power. Plug it in, and then solve for c. Easy. This way you can find out particular solution really easily. Variation of parameter on the other hand, step 1 is just homogeneous part. Step 2 was, what can I say, we required this kind of computation. It was totally unnecessary for previous types of problem, but this time it's different. We need it, so I'm going to copy and paste this part over here, and then instead of naming it as step 2, this is going to become my step 1, because the homogeneous part is unnecessary. We already have those. And let's begin with this thing. Okay, we have y1 as cosine of t squared. So instead of this function, we have u1 of cosine of t squared. And u2 is this one. y2 is this one. So we have u2 times sine of t squared. Okay, that's one of the starting points. And then another one is over here. y1 prime u1 prime y1 plus u2 prime y2 is equal to 0 always. This one and that one, we start from here. Okay, what do you do next? This is your particular solution, u1y plus u2y2. And let's take the derivative using the product rule. u1 prime y1 plus u1 y1 prime. That's the derivative of this product. And then the product rule again for this one. u2 prime y2 plus u2 y2 prime. We just use two product rules. And then let's make this observation. u1 prime y1, u2 prime y2 add up to 0, as you can see in this color coding. So what's left is the black part. And then what you get, you have two products added together. u1 y1 prime, u2 y2 prime. Okay, that's the derivative that's going to be substituted over here. Now let's take the second derivative. From this product here, we use the product rule. From this product, we use the product rule. And we have this computation. It's not hard, just product rule twice. Okay, ready to plug all those in. This second derivative goes over here. And then the first derivative goes over here. And then the original goes to this. And then set up all these and this equation. And we're going to do some simplification. I copied and pasted that from the previous problem, so this line pretty much corresponds to that, except that this line is based upon this equation, which is for previous problem. We have to change it. Right-hand side is 40 to the 5th power, not exponential, so we need appropriate change here. Okay, all right. And then how about the others? Y double prime times t, I need it, so I need t times. And then this one is the second derivative, as we calculated over here in this line. And minus y prime, not 2y prime, so we get just subtraction. And then plus 40 cubed. Okay, all right. Not 5, but 40 cubed. Okay, all right. I think we are pretty much done here. All right, let's do some algebra here. And I'm going to recycle the color coding I already did for the previous problem. Let's focus upon the U1. And what comes with U1? Y1 double prime times t. And with this U1, I have y1 prime, and for this u1 we get y1 times 40 cubed. Put all those together, what do we get? u1 times this y1 double prime, and I need times t, this one, and I lost the color, so I want it back. And then minus y1 prime, okay. And then plus 40 cubed times y1, so that goes over here in place of just 5. Then what do we have? This is the left-hand side of the original ODE, and y1 is the solution of homogeneous equation, so this part will have to be 0. What am I talking about? Let's copy and paste this thing. And this part over here will turn out to be 0. We can do the same thing to all these red terms. U2 is common, U2 is common, U2 is common. And what's the coefficient? Y double prime times t. So this is what I need. T times y double prime. I don't know why I'm losing. Okay, I got the color back. And then minus y2 prime. So this is minus y2 prime. And then instead of 5, I need this 40 cubed. 40 cubed times y2, that comes over here. And instead of 5, I need 40 cubes, so I changed accordingly. What's left will be this part and that, this one and that. Everything else, all the colored part has been counted for. So t u1 prime y1 prime, t u1 prime y1 prime, and this one t u2 prime y2 prime, t u2 prime y2 prime. We get that. So once we copy and paste this thing, this whole part will turn out to be 0, and this whole part will turn out to be 0, And then this part, let's simplify just a little bit. Let's take t out. Let's factor t out. And all this is 0, and then we get that part. So we can divide by t, and then I'm gonna get four t to the fourth power here. In the end, what do you get? u1 prime y1 prime plus u2 prime y2 prime is equal to 4t to the fourth power. There goes one equation. And the second equation is this one. y1 prime u1 prime y1 plus u2 prime y2 is equal to 0. We get these two, and that's where we're going to begin in the next video.